So in this video, we're going to start using u sub. So we're going to start off with the antiderivative of sine x e to the cosine x dx. Now, one thing that I want to point out is whatever's the power is usually u, whatever's the angle is usually u, or whatever you can make equal something else is usually u. So now we're going to write down let u equal cosine of x. So now when you differentiate, you're going to get du over dx equals sine x, negative sine x. So now du, negative du, is going to equal sine x dx. So now if you look over here, you have sine x dx. You're going to replace that with negative du. Usually I just pull the negative here and I put the du here. And now instead of saying e to the cosine x, I could say e to the u. So the antiderivative of this is going to be negative e to the u plus c. Now you could plug in and you could say negative e to the cosine x plus c. Now let's see if that makes sense. The derivative of negative e to the cosine x is negative e to the cosine x. The derivative of cosine x is negative sine x. So negative times a negative is a positive, and it will give us what we have up there. Okay, so now we're going to do another one of these, and then I'm going to have to clear out some room. So now if you have secant 2x, tan 2x, dx. Now, I would probably let u equal 2x. So du over dx is going to equal 2. So du over 2 equals dx. So you have the dx here. So you're going to replace this with 1/2 du, and now you're going to write down your secant x tan x. Let me just erase that so I have some room. So you're going to write secant u tan u du. The antiderivative is, I'm going to put an arrow over here, is going to be 1/2. The antiderivative of secant u tan u is going to be secant u plus c. And now you got to plug in, I'm sorry, and you're going to get 2x. Now let's see if this is correct. The derivative of secant 2x is going to be secant 2x tan 2x. The derivative of 2x is 2 times the 1/2 will give you what you started off with the original. The next one that we're going to do is going to be more difficult. So we have the antiderivative of tangent 4x plus 2 dx. I don't know what the antiderivative of tan x is or what derivative will give me tan x. So that means it's probably a trig function that you could break it up. So now I have sine 4x plus 2 over cosine 4x plus 2 dx. So now I'm going to let u equal the denominator, cosine 4x plus 2. So now when you do this, the derivative of u is du over dx equals negative sine 4x plus 2 times 4. So now I need to make this look like this. So now I could do du over 4, actually make it negative du over 4 equals sine 4x plus 2 dx. So that part is correct. So now I can put the negative 1/4, put the du up here, write the u over here. So now the antiderivative of du over u is an ln. So negative 1/4 ln of u plus c. Now plug in u, and u was the cosine 4x plus 2 plus c. Now I'm going to check this by doing the derivative. So now the derivative of ln of cosine 4x plus 2 is going to be 1 over u, so du over u, so cosine 4x plus 2. And now the derivative of the actual angle is going to be negative sine 4x plus 2 times 4. So when you simplify this, you're going to get negative 1 times 4 is negative 4. Negative 4 divided by 4 is going to be, well, there's a negative and negative here, so it's going to be positive. So it's going to be sine 4x plus 2 over cosine 4x plus 2, which is just going to give you tangent, which is what we originally started with. Okay, the next function that we're going to do is not too difficult. It's not too bad. Root cotangent x cosecant squared x. Which one can you make equal the other one? Can you make cosecant squared equal cotangent? Probably not. Can you make cotangent equal cosecant? Yes, if you do the derivative. So let u equal cotangent of x. So derivative of u is du over dx. The derivative of cotangent is going to be negative, because it's a c, cosecant squared x. So now I could say negative du equals cosecant squared x dx. So now I could say u to the 1/2. Du, don't forget the negative here. So now when you're going to have to take the antiderivative, so add 1. So it's going to be 3/2 divided by 3/2, which means it's going to become 2/3. You're going to flip it. So now I'm going to get negative 2/3 u to the 3/2 plus c, plug in. So now negative 2/3 u was cotangent of x. So it's going to be raised to the 3/2 plus c. And if you take the derivative of this, you're going to have to chain it. So now you're going to get, you have the negative 2/3 here. You're going to have to drop the 3/2. You're going to have to drop the power. So when you drop the power, it becomes the 1/2 times the derivative of the inside derivative cotangent negative x is negative cosecant squared x, and derivative of c is 0. So now this is going to cross out. That's going to give you a negative. Negative times a negative is a positive. So now you have cotangent of x raised to the 1/2 times the cosecant squared x, which is really the root of cotangent of x cosecant squared x, which is what we had up there. Okay, I'm going to do one more, and then I'll do more tomorrow. Okay, so the last one that we're going to do is dx over cosine squared 2x. Okay, now what you have to think to yourself is, do I really want trig identity? No, those are annoying. I'm not even going to lie to you. So now, can I write this into something else I could deal with? What's the same thing as cosine squared? Secant squared 2x. And now we have to start thinking to ourselves, do we know what the antiderivative of secant squared is? Yes, that's tangent. Okay, so you could work with that. So we're going to let u equal the angle. Kind of lucked out. We didn't have to do a trig identity, but pretty soon we are going to get those trig identities. So the derivative of u is du over dx equals 2. So du over 2 equals dx. We have this part. So now I'm going to replace. And now I could say secant squared, that should be secant, squared of u du, and don't forget the 1/2. So now the antiderivative of secant squared is what we said before, tangent of u plus c. So now we're going to get 1/2 tangent 2x of c. And that's it for tonight. Yes, Emma, I'm coming.